We are going over the homework review for Lesson 20. Lesson 20 is solving polynomials. Now, we already know if we have a quadratic, which is a polynomial of the second degree, like something x squared plus something x plus something is equal to 0, then we could solve using the quadratic formula or the AC method or some method we've learned for solving quadratics. We know if it was an x to the third plus something x squared plus something x plus something is equal to 0, if it was set up nicely so that we could factor by grouping, then we may factor. But if it's not set up nicely where it will factor by grouping, then we wouldn't know presently how to factor a third degree polynomial, fourth degree polynomial, etc. And so today's lesson is going to make it to where we can solve more complex polynomial equations. And so what we're going to do to lead into that is learn the rational zero theorem. And the reason for that is remember that we're going to try to find zeros of polynomials. Remember, the solutions would look like this. Maybe we would find the roots like x plus 2 times x plus 3 equals 0 on a quadratic. And then we would say, well, that would create a 0 of x equal negative 2 and x equal negative 3, which is the value of x when y equals 0. So we call the solutions to a polynomial roots of that polynomial or zeros of that polynomial. This here we would call a factor, and right here we would call it the root or the zero of the quadratic. So this is still in factor form, and this actually has revealed the root. And that's kind of important for us to know. When we're looking at the rational root theorem, we're looking for possible roots, okay, possible solutions. If we could just get one solution, we could work our way from a cube to a square, okay? If we could just take one of those roots or factors out. And that's the idea we're going to try to do. The situation, though, is if we're given a polynomial like number 1 on the worksheet, where we had f of x is equal to x cubed plus x squared minus 4x minus 4, then what we want to try to do is kind of think about, okay, if we could find the first root, then we could pull that out as a factor, x minus that root, and that would take us from an x to the third power. When we pull out that x to the first to an x to the second. And then what we would be left with is a quadratic, which we could solve using quadratic rules. So we would like to find a root so that we could create a factor so that we could get down from the third power to the second power so we could deal with it as a quadratic. Now, we think, well, what is a possible root of that? Well, you could have an infinite set of possible roots, the set of all integers, or the set of all real numbers, half, fourth, negative 3, 6, a million. Well, you don't want to have to go through all of those. We're going to use synthetic division to try to find a possible 0, if you recall that from synthetic division. And a 0 will be where you do your synthetic division and you get a remainder of 0. But before we can do synthetic division, remember you'd put your root in there, and coefficients, like the coefficient of x is 1, the coefficient of x squared is 1, the coefficient of x is negative 4, and the constant is negative 4, and you would until you got a 0 for a remainder, and you would know that that was a good situation. And so you take this root and you would put it in there, and what was here would be your quadratic, okay? But the question is, what do we start dividing by? There's an infinite number of real numbers that we could put there. Well, we'd like to narrow the gap down a little bit. You don't want to try an infinite set. You could be doing synthetic division forever if we couldn't narrow it down a bit. Okay, so the rational zero theorem is basically going to help us narrow down our possible roots that we would divide by to try to reduce our polynomial down. Okay? All right, so there's the purpose of what we're doing on the first page of this, and that's going to lead into the second page. I just kind of went ahead and gave you the why. Okay, so let's get back to really what we're doing on the first page. We want to find some possible things to divide our polynomial by. And the way we're going to do that is we're going to take the very last term. Now, notice if we have an x to the third, that we want to keep it going. Second, first, and then to the 0 power, there's our constant. So the very last term we're going to take a look at, I'm going to do that in blue. The very first term we're going to look at. Now, the coefficient there is 1. So we're going to look at the -4, and we're going to look at the 1. Now, what we're going to do is take all of the factors plus or minus all of the factors of that -4 over all of the factors of that 1. And I'm going to put that in green just so you can see. Over all of the factors of that leading coefficient 1. So we'll think, well, what are the factors of 4? The factors of 4 are 1 times 4 and 2 times 2. So we're going to have plus or minus 1, plus or minus 2, plus or minus 4 over the factors of that leading coefficient 1, 1, 1, 1. And then we come up with all the results. So we're going to have positive 1 over 1, which is 1. And then we're going to have negative 1 over 1, which is negative 1. And then we're going to have positive 2 over 1, which is 2. And then negative 2 over 1, which is negative 2. And then positive 4 over 1, which is 4. And then negative 4 over 1, which is negative 4. If we were to line those up from least to greatest, our set of all possible rational zeros are negative 4, negative 2, negative 1, 1, 2, and 4. Now that's possible. Notice we didn't say real zeros. We said possible rational zeros. Possible rational zeros. And we do have possible. Rational means there's not a square root attached to them, or some other rational number like pi. These are rational numbers. So that means if it's an x to the third power, there's 3 possible zeros. There would be 3 roots. And so we'd have x equal, x equal, x equal. There's 3. It's possible that 2 of those are from the set negative 4, negative 2, negative 1, 0, 2, and 4. Now, irrationals and imaginaries come in pairs. So if you had one imaginary, that means you'd have 2 imaginaries, so you'd be left with 1 rational. Anyway, when we try our synthetic division later on the test, we would only choose from those to try to find a hit so that we could reduce from an x cubed to an x squared. Okay? Any questions on number 1? So here's the answer to number 1. This is the set of possible rational zeros for that cubic x cubed plus x squared minus 4x minus 4. Okay? All right, number 2. Question number 2, we have a quartic. We have 4x to the 4th minus x cubed plus 5x squared minus 2x minus 6. And our final coefficient, our constant, is negative 6. And our leading coefficient is 4. And so we're going to put the factors of 6 plus or minus the factors of 6. The factors of 6 are 1 and 6 and 2 and 3. So we're going to have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6 over the factors of 4. A little more complicated than number 1. 1 or 2 or 4. 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 And then we get all those combinations. We're going to have positive 1 over 1, which is 1. We have positive 1 over 2, which is a half. We have positive 1 over 4, which is a fourth. And then we have the negative 1 over all three of those. Negative 1 over 1, negative 1, negative 1 over 2, negative 1 half. Negative 1 over 4, negative 1 fourth. Okay, see what's happening? And then we go to the next one. That all came out of that first little bunch. And then we've got positive 2 over 1, positive 2. Positive 2 over 2. 2 over 2 is 1. Positive 2 over 4. 2 fourths is a half. And then the negatives. Negative 2 over 1. Negative 2. Negative 2 over 2. Negative 1. Negative 2 over 4. Negative 1 half. Then we go to the next one. Positive 3 over 1. Positive 3. Positive 3 over 2. 3 over 2. Positive 3 over 4. 3 over 4. Then we go to the negatives. Negative 3 over 1. Negative 3. Negative 3 over 2. Negative 3 over 2. Negative 3 over 4. Negative 3 fourths. Then we go to the next one. Positive 6 over 1. Positive 6. Positive 6 over 2. Positive 3. Positive 6 over 4 reduces to 3 over 2. Negative 6 over 1. Negative 6. Negative 6 over 2. Negative 3. I'm going to stick it up there. Negative 6 over 4. Negative 6 fourths reduces to negative 3 over 2. Wow, that's a lot of them, but it's better than infinity, isn't it? When we go to trying to choose one to do our synthetic division with in a minute, we're probably going to avoid the fractions as much as possible and try to start with 1 and negative 1 and 2, negative 2, and then if those get crazy on us, we'll go back to half and negative a half and stuff. But at least we don't have an infinite set to choose from. Now, let's line these up from least to greatest, but let's watch. We've got a 1 here, and we're going to look for another one, so we can just chunk that one. We've got a half here, so we've got a 1 here, and there was another 1, and then we've got a half, and if we look down through there somewhere, we have another half right there that we can cast out. We've got a fourth, and I don't see another fourth. We've got a negative 1, and there's a negative 1 right there. We've got a negative 1/2, and I see another one right here. We have a negative 1/4, and I'm not seeing another one of those. We've got a positive 2, and I'm not seeing another one of those. We've got a negative 2, and I'm not seeing another one of those. We've got a 3 here, and then there's a 3 here, so we'll cast out that 3. We've got a 3/2 here, and there's another one here, so we cast that one out. We've got a 3/4, so I'm not seeing another one. A negative 3 right here, and there's one there. We'll cast it out. We got a negative 3 over here, too. We'll cast that other one. And a 6, negative 6. That looks like it. And so we're going to line those up from least to greatest. The least would be a negative 6. That's that one. The next least would be a negative 3. The next least would be a negative 2. That took care of that. There's my negative 3. Negative 3/2 is negative 1/2, so it would be next, negative 3/2. Then we would have our negative 1. Negative 1 is here. Then we would have a negative 3/4. Got to kind of think about fractions a little bit here. Then we're going to have negative 1/2, excuse me. And then we would have a negative 1/4. After that, you're kind of going the other way with positives. See the 1/4 again? Then you got the 1/2. And then you got the 3/4. The same numbers reflecting. It's just now they're positive. See, so it got a little easier when we go to grab the others. 3/2, 2, 3, and 6. Okay? And so there's the set of all possible rational roots. The set of all possible rational roots. So later, when we try to do the synthetic division to pull out a factor so we can reduce from the 4th power down to the 3rd power, then that would be our choices. And what would happen, and this looks fun, doesn't it? You would do some synthetic division and take it from a 4th to a 3rd. Then you would have to do it again to try to take it, synthetic division again, to take it from a 3rd to a 2nd. But remember, you don't have to do all of this rational root stuff again, because it's the same polynomial. When you go from a 4th to a 3rd, it's going to have the same possible roots, right? So we would pick again from this list to take it from a 3rd down to a 2nd. Okay? All right. Any questions on 1 and 2, finding the possible rational zeros or rational roots? The 0 would lead us to a root. Okay? Now, what we want to do on the next page is we actually want to find all of the zeros. So we're going to apply the synthetic division to this. So we're going to take what we just did one step further. We're going to take what we just did one step further. Okay? And so we're going to take f of x is equal to 2x cubed minus 3x squared minus 11x plus 6. And we're going to actually try to come up with all of the factors and get all of the zeros. Now, we know there's 3 factors and 3 zeros. And what we're going to do is we're going to take it from a 3rd power down to a 2nd power. And when we get it down to a 2nd power, we'll use quadratic rules to go from there. So what we want to do is we want to do a synthetic division with this. We want to pick a number to put in here, and then we're going to take our coefficients. X cubed coefficient, x squared coefficient, x coefficient, and then the constant. If there was a missing one, we'd have to just stick in a 0, right? And so we're going to have 2, negative 3, negative 11, 6. We've got ready for our synthetic division, but we've got to figure out what to choose to put in there, okay? And we're going to do that using the rational zero theorem. So we're going to take this last, that constant term, and we're going to do plus or minus all of its factors, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, over the factors of the leading coefficient, 2 or 1, 2 or 1, 2 or 1, 2 or 1. I could have said 1 or 2. And then we're going to get the combinations. 1 over 2 is a half. 1 over 1 is 1. Negative 1 over 2 is negative a half. Negative 1 over 1 is negative 1. 2 over 2 is 1. 2 over 1 is 2. Negative 2 over 2 is negative 1. Negative 2 over 1 is negative 2. 3 over 2 is 3 over 2. 3 over 1 is 3. Negative 3 over 2 is negative 3 over 2. Negative 3 over 1 is negative 3. 6 over 2 is 3. 6 over 1 is 6. Negative 6 over 2 is negative 3. 6 over 1 is 6. If I cast out the doubles, there's a second 1. There's a second negative 1. I have a couple of 3s. I've got a couple of 6s. I've got a couple of negative 3s. If I take the left and line it up least to greatest, then my possible rational zeros from least to greatest, I should have had a negative 6 somewhere. I think that was a negative 6 that I shouldn't have cast out. Sorry about that. I would have had a negative 6, negative 3, a negative 2, a negative 3 over 2, which was a negative 1 and a half. I would then have a negative 1, and then a negative 1 half. And then I would have a positive 1 half, a positive 1, a positive 3 over 2, a positive 2, a positive 3, and a positive 6. Got kind of weird to do that. Sideways, crooked, whatever. So there's our possible rational roots. Now, we usually, when we have those choices, we'll usually just start with 1 or negative 1 and throw the half in there later if we need to. So what we're going to do is we're just going to pick one, okay? I'm just going to start with this and say, well, 1 was one of the possibilities, so I'm just going to stick it in there. We're going to do synthetic division. Now, remember when we do synthetic division, we bring down, and then we multiply 1 times 2, right? And 1 times 2 is, I shouldn't have bounced it that high, is 2. And then we add, and you're going to get a negative 1. And then you just keep multiplying. You multiply 1 times negative 1 is negative 1. And then you add and get negative 12. And then you multiply 1 times negative 12 is negative 12. And then you add and you get negative 6. And it's not a 0. We look at the remainder. It's not a 0, so it's not a root, so this didn't work. We do know, though, that it's a point. The remainder is the function value, so we do know 1, negative 6 is a point on the graph. But we want the values of x that make y 0 so that we have a 0 or a root. So that didn't help us as far as breaking this thing down from a cubic all the way down and finding the zeros. But you might remember that when you plot these points, if you were going to graph at some point, you could stick that point on the graph. That could help you there. Well, that didn't work, so what we do is we just start again, okay? I know some of you on your paper show all your tries, and some of you, just since it's going to take a lot of paper, you just kind of erase out all that work and start again. So that didn't work. We can just kind of trash that one. So let's try a -1 and see if it'll work. So we're going to start our process. We're going to bring down the 2, and then we're going to multiply. -1 times 2 is -2. And then we're going to add and get a -5. And then we're going to multiply, and we would get a +5. And then we would add and get a -6. And then we would multiply, and we would get a +6. And then we would add, and we would get a 12. We thought, oh, we almost got there. We thought we had a 6, but it was the wrong sign. And so we have another solution. We have another point, but that doesn't give us a 0, so that didn't help. And so -1 is not a root. So we tried 1. It didn't work. We tried -1. It didn't work. And so now we're going to try uh, 1/2. I think I may have made a mistake in there. Is why I was going but it wasn't going to have effect. So we'll keep going. I may have made a multiplication error there, but it still wasn't a root. So we're going to have a 2, a -3, a -11, and a 6. So I'm going to keep moving. So you may have recognized an error there. I'm not sure. So anyway, so here we go. We're going to try +2 now. We're going to try +2. We've tried 1 and -1, and it didn't work. So we're going to put in a 2. We're going to go through our process. We're going to bring down, and we have a 2. And then we're going to multiply. 2 times 2 is 4. And then we're going to add, and we would have a +1. And then we would multiply, and we would have a 2. And then we would add, and we would have a -9. And then we would multiply, and we would have a -18. And then we would add, and we would have a -12. And so we also then have the point when x is 2, y is -12. It's a point on the graph, but it wasn't a 0, so that didn't help us either. So we've had 3 misses, and you think, wow, this could last forever. Well, really, it can't last forever because we have created a list that's not forever long. It looks pretty long, but it's better than infinity, right? And so we try again. And so we're going to try -2. And so we're going to bring down, and we get a 2, and then we multiply. -2 times 2 is -4. And then we add, and we're going to get a -7. And then we're going to multiply, and we would get a 14. And then we would add, and we would get a 3. And then we would multiply, and we would get a -6. And then we would add, and we get a 0, and yippee, we got a 0. All right? Now what that means is we have a y of 0. That means we have an x-intercept. And the x that made that y 0 was a -2. So we have one of the solutions, one of the zeros of this quadratic is x equal -2. What that looks like as a factor, though, remember our factors are x minus the x. So it would be minus a -2, and so really that factor is an x plus 2 if the 0 comes out to be -2. Remember that? Okay? I wanted to have that in place down there so you could see what those look like. Okay, now here's what we've got then. We've actually got x plus 2 times the quadratic, see? So what happens is when we take this cubic and we take out a factor with an x in it, it's going to reduce it to something inside with an x squared. And so the result down here is going to go from an x to the third to an x to the second to an x to a constant. And so what we have in here is 2x squared minus 7x plus 3 equals 0. So we found the first root, or 0, by its rational root theorem, creating a 0 remainder in synthetic division, and we can also see what the factor looks like, x plus 2. What's left inside here is a quadratic, and so what we will do at this point to find the other two roots is use the quadratic formula. Okay. We're going to use the quadratic formula. So let's take a look at that. What we have now to solve is 2x minus 7x plus 3 equal 0. We could try to use the AC method and get factors, or use the quadratic formula and skip the factors and go straight to the roots, correct? Straight to the zeros and skip the factors. So we're just going to use the quadratic formula. We're going to have A is 2 and B is negative 7 and C is 3. And so we have x is equal to the opposite of B, negative 7, plus or minus the square root of my B, which is negative 7 quantity square, minus 4 times my A of 2 times my C of 3, all over 2 times my A of 2. Now I'm going to do this and this and this. And so I'm going to have x is equal to the, which is a positive 7, plus or minus the square root of negative 7 quantity squared is 49. 4 times 2 is 8 times 3 is 24. When you multiply with an odd number of negatives, the answer is negative. All over 2 times 2 is 4. I can now do 49 minus 24, and I would get a 25. And what I'm going to do is just come back up here to the top and get rid of some of this. I'll just kind of get rid of it as I go. I'm going to go ahead and put f of x back in there. Okay? And so when I move this up here, then what I have is x is equal to 7 plus or minus the square root of 25 over 4. 49 minus 24 was 25. We now can take the square root of 25, which is 5, and so we're going to have x is equal to 7 plus 5, 7 plus or minus, 5 over 4. Okay? I'll move this to the side in case you need to see that for a while. Then we'll just move this over here. So we're going to have x equal 7 plus 5 over 4, or x is equal to 7 minus 5 over 4. Seven plus 5 is 12, divide 4 is 3. 7 minus 5 is 2, divide 4 is a half, and so my other two roots are 3 and 1/2. So there are the zeros, roots, solutions to this x to the third power. Any questions on how we got that? Okay. I'm going to stop right there and just make this part 1 of the video so my videos aren't too long, and then I'll continue recording and call it part 2. Thank you.